Hello. Thank you for joining us for our 5th ShipIt event. This is our virtual event series where we get together and nerd out all over the tech that we love right now. With conferences being canceled and postponed, we miss having those vital connections we make with you all in person. Community is super important to us at Shopify, and we really want to find a way to connect with you in this virtual space. My name is Anita Clark, and I'm the managing editor of Shopify's engineering blog. I also do some tweets on our Twitter account. Today, we're here talking with the members of the team that built Shopify's API health report. Thanks for joining us all here, you guys. Please introduce yourselves.
Hello, my name is Shuting. I'm a UX designer on Shopify developer platform, and my focus is basically to improve the user experience for developing for Shopify.
Hi, my name is Vrishti, and I work as a data scientist on developer platform data team.
Hey everyone, my name is Robert Saunders. I am a developer on the API patterns team, and I mainly work on solving practical API design and implementation problems at Shopify.
Hey everyone, I'm Karen. I'm a developer on the app management team at Shopify.
Okay, so today we'll be talking about the API, the building process of the API health report. So before we get started, let's take a look at the product background. So Shopify introduced API versioning in April 2019. So after that, a new API version will be released every quarter. The intention is to provide a predictable timeline for our third-party developers, so it's easy to plan the development and adopt new features. After a new feature is released, apps have 9 months to adopt those new changes and take advantage of the new feature before the older behavior is no longer available. So we understand that stay up to date with Shopify takes valuable development time from our third-party developers. To make it easier for developers to stay on top of coming versions, we introduced a tool in the partner dashboard, API Health Report, which is a topic for us to talk about today. Initially, there are 2 major problems we're trying to address that block our developers to stay up to date. Firstly, Shopify API is a relatively new concept that not everyone is familiar with or aware of. Secondly, there are many new features that are offered in one API version. Many. This is a time consuming to extract the information from full documentation that's relevant to one app. So the goal of API Health Report is to ease the process of fixing breaking API by surfacing app-specific API call data in the Shopify Partner dashboard. Our engineer team will dive deeper into the concept of breaking API later. Now let's focus on the user experience. To raise awareness of API versioning, we decide to surface versioning information on the most visited page, the app index page. So if we take a look at the page on the second column, we introduce this new column called API Health, and that's communicate how up to date an app is. Clicking on the status on the API Health column will enter the detailed page that lists all the breaking calls that affect one particular app. Each item links to the specific page in the developer doc. This is to address a problem that we previously mentioned, so developers don't need to browse the full doc, but have the meaningful information surface to them directly. The initial UX exploration, as we're seeing today, is a data table, but it's not so exciting to look at. Also, the action we want the developers to take isn't clear. The urgency and the workload was also not well communicated. Another version with highlighting how an app is impacted by different API version was explored. But the page looks really overwhelming and confusing to me, even though I designed this. So this is not the experience that meet Shopify's UX standard. At the time, I wasn't happy with the outcome. And the answer for better UX always lies between user needs. We interviewed many internal developers and figured that knowing what needs to be done is only step 1. for any developer team, it's always important to know how to plan and prioritize. That should be the new goal that UX design can help to achieve. So as we can see here, a timeline concept is introduced. Breaking changes are categorized by urgency. So a clear action item is assigned to each group. The information now is simplified and a lot more easier to read. The next step is usability testing. Shopify developer community is highly diverse. We reach out to the developers across the world to test the prototype. The detailed page was well received, while the confusions are mainly around the summarized API health status. If we look into the left-hand side, we realize the term we pick were around opinions rather than fact. We call it up to date or update available or breaking soon. But how soon is soon? Opinions could be interpreted in many ways that cause the confusion. So then we adjust the copy to iterate into update deadline to reflect the truth, and the colors are adjusted with additional outlines to meet the accessibility standard. So the page of the initial release are finalized now. I hand over to the true heroes behind this project, our engineer team.
Thanks, Shooting. So now that you understand the product and the experience that we wanted to create, let's jump into some of the infrastructure that we created to power it. At Shopify, there are lots of teams who develop APIs. For example, the orders team is responsible for the order API. And similarly, the merchandising team is responsible for the product part of our API. With that in mind, it was essential for us to create tooling that was easy to understand and use by many developers. The first aspect of making this easy for developers at Shopify was to clearly define and communicate what an API version entails, and more specifically, how they could introduce API changes. We started by creating two objects, an API version and an API change within our codebase. An API version represents a distinct API version and has some metadata around that version. And similarly, an API change represents a change in an API version. So as you can see from the illustration, an API version is made up of API changes. Here's an example of an API version definition. We define API versions in a YAML file, but use them as objects in our code. Similarly, here's an example of an API change. They're also defined in YAML, and we store some useful metadata about the change and the version is related to. The API change definition is really the foundation for all analysis we perform on a specific API change. It lets us differentiate and track API changes within our code base. When thinking about API changes, we group them into two main categories, breaking and non-breaking changes. A simple way to think about it is a breaking change is any change of functionality that would require a migration for an API consumer, such as renaming an API endpoint or a GraphQL field. In contrast, a non-breaking change is any change that can be adopted without making any changes to how you consume the API. The API health report is purely concerned about communicating what breaking changes will affect a particular API consumer. To provide that information to API consumers, we need to observe what code paths they are hitting that will break as a result of a breaking API change. We leverage our API change definitions by referencing them, their handles, and helpers that we've created throughout our code base to do that. So let's take a look at an example. So take the hypothetical case. Shopify has decided to remove the orders index endpoint in our admin REST API in the next API version, 2020-10. This would be a significant breaking change and one that we would want to let developers know about in the API health report. First, we would define our API change. Here you can see we've named our API change remove orders index API, and we've set the version handle to be 2020-10, since that is the version our change is becoming effective. Then we actually need to change the functionality for that specific API version. We can't just remove code for that endpoint because older versions still rely on it. This is where the helpers that we created come in handy. So first, let's take a look at the code currently. So here in the example, you can see that we just find the orders and return them. Since our API change removes that route completely, we need to return a not found error if the API change is in effect. In this case, that would be true for any request made to an API version greater than or equal to 2020-10. To implement that, we have a nice helper called API change.inEffect. So as you can see in the snippet below. API change.inEffect is relatively straightforward. You pass the API change handle from our API change definition, and it will return a Boolean result, true if the change is in effect under the current request context, or false if not. API change.inEffect is great for performing the conditional logic and actually implementing the API change behavior. However, it doesn't provide too much visibility into how API consumers are using the API change. For that, we have another helper, API change.markBreaking. We place mark breaking calls in the code paths that will eventually break, i.e. when the API change exists in all the API versions. Its core purpose is to emit events to our data warehouse by way of our Kafka implementation. So if we update our example, when you call mark breaking, we capture all of the request information, construct a hash with the relevant information we want to send to our data warehouse, and then send it off via our Kafka implementation. For those not familiar with Kafka, it is an open source event streaming platform. But here you can see that we've updated our example to call .mark breaking in the case of where the old behavior is being served, because that is the breaking behavior eventually. So that's the general gist of how we introduce API changes and how we analyze them so we can surface the information to our developers. To recap, we define an API change and attach it to an API version. We then update our behavior to implement that change with the .inEffect calls, and then we add .markBreaking calls to store information about how API consumers that are still using the outdated behavior. There are a few more cases I haven't had a chance to talk about due to time constraints, but if you're curious about how .markBreaking and some of its more complex use cases, Tom Newton, our VP of Engineering, wrote a great piece on it. You can check it out in the show notes. I'm going to pass it off to Vrishti to share what happens once our Kafka events make it over into data land.
Thanks, Robert. So I will walk over constraints and steps taken to build the report from a data perspective. One of the main constraints when architecting the report was that we wanted to ship it quickly. We only had about 2 months to build the report so that we could notify partners well before the deadline for them to update their API versions for the first versioning deprecation. The second challenge was handling heavy volumes of data. There are about 500 billion or more breaking calls being made in a given week, just to give you an idea of what I mean by heavy volumes. And lastly, we needed to deliver with systems we already had in place. So with these constraints in mind, we decided to use our data pipeline, which is not designed for a product-facing feature like this, but we used it to streamline the data for the API health report. And there were 3 main steps, as in any data pipeline, which we took advantage of to deliver this data. The first was extracting from Kafka. The second was transforming it using PySpark in our data warehouse. And the third was loading the data to Google's BigTable to allow client libraries on the front end to consume it. So for the first step, extraction from Kafka, we needed a track of logs for each API call made to a breaking change, which was provided by the events emitted to a Kafka topic, as Robert described earlier. So to retrieve those logs of API calls, we used 2 in-house tools to help us with the process. The first was a Spark extractor that converts the Kafka topics data to a Parquet format and stores it in our data lake. And Parquet is just a format for storing columnar data for efficient querying. The other tool was something that allowed us to schematize the Kafka topic. This was to ensure that the topic would fit the schema as shown in the simplified version of the table. And of course, this step ensured that we could jump into the next step directly without needing to make sure that the incoming data is formatted as expected. So for the second step, transforming the data in in our data warehouse. From our previous step, we already had data in Parquet files in a specific format. So we now needed to transform it for delivery. One of the main factors that drove our transformation strategy is the volume of data that came in through the Kafka topic, which is the constraint I mentioned earlier. So we needed a way of compressing the input data to an output that looks something like this. Here we're basically calculating the last time a call was made for an app, change handle, and endpoint, and passing that as our output. We wanted to do this without looking through all the 500 billion rows of data so that we could deliver the data as quickly as possible. And we did that by storing the compressed output of the first set of events and using that in our transformation with the new set of incoming data from Kafka. So what that means is we used our previous output and the new data generated to avoid looking through the history of all the calls and pick the last time a call was made to an app, change handle, and endpoint. And for the last step, we needed to load this data to BigTable. To do the loading to BigTable, which is, by the way, a key value store, so you can also think of it like a dictionary where we use the app ID as our key and rolled up all its meta fields as the value. And so for this step, we used a script with an output schema specified in Avro to do the loading. Using our example from the previous step, the Avro load looked something like this, where the only other field that we added to it was stop threshold, and this was to indicate when the data rollup was calculated. And next up, Karen will describe how this data was consumed.
Thanks, Rishti. So now that we have the groundwork laid out to get the required data into the data system, we need to get that data out and present it to the app developers in the API health report. So how does that work? An app developer navigates to the API health report for one of their apps, and the front-end React application fires off a GraphQL query to retrieve the report. So the query is given an argument of ID, which is the app ID, and with GraphQL, we can specify which fields we want to retrieve. So in this case, we want to just get the breaking API changes for the specified app. And we're getting the stop threshold, which is the timestamp of the last refresh of the data. And we're also getting a list of all the breaking changes. And for each of these changes, we're getting some useful information that we need to show in the API health report. So things like the handle of the breaking change, the version, the deadline, the timestamp of the last time that was called, and other information. And so when the GraphQL layer receives this query, it delegates to a backend process that retrieves the data from the data system. As Rishti mentioned, the data is stored in BigTable, but in order for Shopify applications to be able to access this data, the data team built an API and client libraries to do that. So why did we decide to use this particular system, like this data system, from an engineering perspective? Its goal is to provide data to applications in a highly available, low latency fashion. It's especially well suited for retrieving data for specific assets or small groups of assets. So from an engineering perspective, it made a lot of sense for us to use it because it fit our purposes perfectly, which was accessing a collection of breaking calls by a single app. So the backend process queries for the breaking changes for the app using the client library and then processes that data. The data is then returned to the GraphQL layer and then returned to the front-end application. In the front-end application, we then group the data based on the deadline at which the app needs to stop making these calls. And once the data is massaged into a suitable format, it's displayed using the timeline component. The API health report contains information about API calls that a specific app is making that are known to be breaking in some versions of our APIs. So when building the timeline component, we knew that we would need to build it in a flexible way because the number of API versions and breaking changes per version would vary depending on the app. And the data is in the format of an array of versions, and each API version is represented by a section component in our code. So here you can see in this red box on the right-hand side, that's one API version, and then there's one below it. And each version is then broken down into a header and a body, where the header shows the information for the API version, and the body displays the specifics of the breaking changes. The header includes information such as the version that we want the app to be migrated to, what the status is. So if we're further away from the deadline, then we don't want it to show up as very urgent. But if we're closer to the deadline, we want it to be a little bit more urgent, so we change the color to red. We also show the deadline and how much time there is left until the deadline. And the section body takes each of the breaking changes and displays them in a table, where each row is a breaking change. And we do a little bit of formatting so that we can highlight the most critical information, such as the change handle, which is in bold here in each of these rows, and a link to documentation to give app developers more information about the change. So that's how we built the API health report. The report has been pretty well received by our app developers. We just went through the first deprecation of our APIs in July, and the API health report was one of the key tools available to support APIs. With that, I will hand it back to Anita to get the question and answer section started.
I need to pull my mic down. Thank you, guys. That was great. So let's start off with some questions here. We do have a question that was asked in the chat and answered in the chat, but I'm going to share it with everyone here just in case no one else got to listen to it or see it, actually. So the question is, so when you say a new API version, do you mean breaking changes or deprecations that third-party developers have to adapt to? If yes, what warrants breaking changes every quarter? That sounds aggressive. Why didn't you just choose a more revolutionary approach to building APIs that many thought leaders advocate? And that's API evolution. There's a link there in Dimitri's question for people watching that you can click and take a look at that, that information. But one of our lovely shop folk has answered this question in the chat, so I'll just read it out for you guys, mostly for the video than anything else. A new API version doesn't always contain breaking changes or deprecations. If we do introduce breaking changes or deprecations, they would be tied to a new version. I think the goal is to have a concept of API evolution in tandem with the versioning strategy we went with. The goal should always to be avoid breaking the API contract, and backwards compatibility should be top of mind. When backwards compatibility is not possible, we have a predictable release schedule to make the adaptation easier. And I hope that answers your question, Dimitri. The next question we have is, when you rolled up the data, the raw data, how did you choose to roll it up by last call time?
So for this, we chose to take the latest call that was made from an app to an API change and endpoint. So what that means is we basically took the maximum of the timestamps that we had in our previous output and the new set of input events that were coming in from Kafka.
Was there any, was it a hard decision to use this particular field? Was it the easiest way, or was there a discussion going on about what your team thought might be the better way of doing that, or the best way? Was there more options you had to choose from?
I guess this decision was based on the design that we came up with. On the page, we decided to only display the last call that was made. So that's why we took the maximum of the event timestamps.
Cool. Well, here's a good question. Why did you decide, well, not just you guys, because you guys aren't the only ones making the decisions in these things, but why did Shopify decide to use GraphQL instead of REST when we made that switch? Anyone want to take that one?
Yeah, I can talk a little. There is public API docs, the benefits of GraphQL link that. So I definitely go rec. So I can talk a little bit. The first of which is a first class GraphQL, the declarative nature.
Robert, I'm going to stop you. I don't know if it's just me, but your sound sounds kind of weird. Is that just me, or is it everyone? Please.
Yeah, he sounds like a robot.
Okay. Okay, just making sure. I'm like, am I the one that's like having the issue here, or is this like everyone's problem? So I don't know if you have a bunch of things running on your machine or something, but say something now. Hopefully you don't sound like a robot.
Is that better? Is that
No.
better?
Oh my God.
No.
It's kind of hilarious. It's not like you're not. We can understand you. It just sounds really funny. So I guess I'll let you continue on with the question because I don't know what's going on here.
How about now?
Yeah.
Robert, I can try to answer this question if you want to try
Thanks,
to fix your audio.
Yeah, you can like pop off and pop back on if you want.
So the question was, why do we choose GraphQL over REST, right?
Yes.
Is that correct? Okay.
Yes.
So I think Anita kind of alluded to it, that it's kind of a organization-wide switch. And there are a lot of benefits to GraphQL. So one of the benefits is that for REST, you're usually accessing a single endpoint for a single resource. So for example, for our application, we're getting the app. So if we wanted to get like a bunch of data for a single app, we would access an endpoint for the REST API, and we get everything. It's all or nothing for REST. But for GraphQL, we can specify exactly what fields we want, and that allows you to cut down on the amount of data that comes back. So if you have like a connection that's not so great, you don't want to like take all that data, you can just specify that you want a single field or like a set number of fields. And it also allows you to group queries together. So if we wanted to get like an app and some other data about an app that's on a different endpoint, for REST, we would have to do multiple calls, requests. And before GraphQL, we can group those together, and you can do one call, and you be able to get everything that you need. And I think that's one of the most powerful things about GraphQL, at least to me.
Any of the other sides of the equation, data, UX, do you have anything to comment about GraphQL over REST in your particular side of the business? No? Okay, cool. Let's go to the next question, and I'll get that up here for everyone to see. Robert, you mentioned that there were some more complex scenarios involving dot mark breaking and dot in effect. Can you talk about why those, what about those scenarios and why they sometimes when they arise?
The audio now is it better? No. No.
This is like the best thing ever though, because it's like, it's almost kind of Darth Vader-ish, so it's kind of hilarious, but.
Does someone else tackle with the Terabon?
Karen, can you take this? Like Robert, you can actually physically like shut down your browser and come back in.
I actually am not too familiar with this part of the code. Robert and his team were the primary like developers of this section. Maybe we can come back to this question.
Yeah, for sure, for sure. Because yeah, we gotta wait for him to get rid of that Darth Vader voice on us. Okay, there's another question coming up. There's a lot of data being processed here. How frequently does the data get refreshed, and how do you decide what is an appropriate level of data freshness?
So we chose to have a latency of an hour, mainly because that gave us enough time to process the data and load it to BigTable and have front end consume it as well. Sorry, I'm just reading the question again.
Sure, sure. Let me know if you. What is an appropriate level of data freshness?
We knew that we couldn't do with the constraints of like using the systems that we already had in place. We couldn't do provide real-time data. We chose to do an hour latency because of that as well, and also that gave us enough time to transform it. Yeah.
Cool. Hey, Robert.
Okay, is it any better now?
You're amazing now.
Yes, okay. Oh, I'm sorry about that, everyone.
That's okay. It was kind of fun. So we're going to go back to your question. I'm going to read it out again. You mentioned that there were more complex scenarios involving mark breaking and in effect. Can you talk about some of those scenarios and why they would arise? Yeah,
totally. So there's two main scenarios that I was particularly referencing when I said that. And the first of which was if in our code base, we have a lot of cases where it's not just one conditional with dot in effect. So you're not necessarily just checking if the API change is in effect or not. Sometimes we'll pair those with other conditionals. So a good example would be, say we had an API change to remove a specific parameter that we need for an API request. Inside our code base, what we'll do is we'll check if the API change is in effect. We'll also check if that parameter is there or not. Like the more complex cases kind of come from when you have more than one thing to check and not just checking the API if it's in effect or not. The second case that I was referencing was we have this other helper that I didn't mention, which is mark possibly breaking. And so we use mark possibly breaking when the request might break. If anything else, if everything was kept the same, it might break, not will break. So in our example, when we remove the endpoint for the orders index, that will definitely break any app that calls that because it just does no longer exist. But say we no longer want to return a specific attribute in a webhook payload or something. We don't actually know how the API consumers are using those attributes, if they use it or not. So we don't actually know if it'll break their app. And so in those cases, we use the mark possibly breaking helper. And yeah, so those are kind of like the two specific cases that I was referring to. But yeah.
Cool. Okay, the next question is, can we talk a little bit about the UX techniques that was used? This can be for this specific project or it can be in general.
I think this project isn't super special. Maybe I can talk about it like in general. So a couple UX techniques. Maybe we can start with how we work as a UX developer for technical audience in Shopify. So in Shopify, we value a lot about cross-discipline collaboration. So from a UX designer perspective, it's always important to collaborate with engineer and product. So in that way, one of the technique we use is called like iterative design. So I will always come up with something, and after that, we'll do a design workshop. So in that workshop, we can do maybe we can validate our assumptions, or we do design critique. And in that way, I can get input from all disciplines onto the design I'm creating, rather than I just only bring my own opinion and have that as a true source of the UX design. That's what we came up with. Some other techniques we have been using. One is, of course, user interview. It's a good thing to work on developer tooling is that I'm surrounded by developers, of course. So many times I can talk to a lot of like internal developers to understand what matters more, because ultimately when we talk about user experience, even the audience is developers. Developers are still human beings, and we really value that. So we will always talk to our team member to understand from like a regular user perspective, what would be his expectation. And in terms of user interview, we also do usability testing and the user research. So in those two type of activities, we'll reach out to the external developers, which are our partners, and we'll basically validate what do they need, what's our pain points, and how they understand in design. Is there anything we can do better to smooth out the initial experience when landing on a piece of product, and how to make sure the design is useful for our developer partners. And that's it.
Great, thank you. Okay, so we have another question. When you say that there are some changes where you don't know if they're breaking, can you talk more about this? And how do you notify the right people if you're not sure if the changes are breaking?
Yep. So first of all, for the possibly breaking case, we still surface those in the API health report, except for there's like a little caveat. It's like, this might be breaking your app, instead of it's definitely breaking your app. And when we say we don't know if they're breaking, what I mean by that is we really do not know how they're using how they're using that response in their app, right? So I think like a good example is in webhook payloads. We change the webhook payload, but we don't know how that app is actually using and consuming that webhook payload. So if we remove an attribute that's in that payload, that app might be using that attribute, or they might not be. And in the case where they are using it, it would break their app, but in some cases, if they're not, it doesn't break their app. So that's why we have this special caveat case for the possibly breaking scenario. And I think, Vrishti, I don't know if you want to add to this, but I think the possibly breaking case gets handled a little bit differently in Dataland because we have different metadata for them, right?
Yeah, we basically pass back a flag to the front end, which was not shown in the examples that I used, to indicate that if the call was possibly breaking, just so that that can be registered on the front end, and it's not a required change. That's about it.
So from a UX perspective, for those surely breaking changes, if the changes has not been fixed before the deadline, or like after the deadline, we'll put up a banner to warn developers they are impacted by this breaking changes. And for those maybe breaking changes, actually we don't put up those additional information banner up, but we still decide to surface those in the breaking API report, because we actually don't know. But if the app is breaking, there potentially the merchants could be impacted, even though we're not entirely sure. But we want to be like 100% sure that their business won't be impacted, because we don't know. I think apps in general are a really important part of Shopify ecosystem. So if we can improve the app's quality to help the merchant have a stable business, we'll just try like any means. And another hand, on the UX perspective, is when we try to put up those maybe breaking information in the report, is actually become extra confusing, because developers they feel during the usability study, they feel like they're concerned about this. So because they don't fully understand, not everyone is fully understand the meaning of it. So we decide to like surface the information equally to reduce that confusion and concern, because the more information, sometimes when we introduce the information, we want to be clear. And when we're not sure if we're entirely clear, we're just trying to trying to have like a clear action item for developers. That's always more helpful than we are taking this gray area attitude that's confused everyone.
Great. Okay, our next question is, how does the deciding to introduce a breaking change versus preserving backward compatibility look like?
Yeah, I can talk a little bit about this. So one thing that we didn't mention was the mark breaking calls aren't just used for the API health report. They're actually used to measure impact before we introduce API changes. And so internally, we have an impact assessment tool that we can use to weigh the actual impact that an API change will have on our developers. And so we take like a breaking change very seriously, but based on the impact as a team, we'll come up with a decision on whether or not this breaking change makes sense, or if it is something that we should consider to preserve that backwards compatibility. So internally, we actually call, when you put mark breaking calls in the code before an API change, or you've decided to put an API change in place, we call it the reconnaissance phase. It's kind of fun.
Now, can you go in a bit deeper into that? Is there like a committee or something that reviews these things and decides, like obviously people from partners and the engineering side? Is it like a multidisciplinary group that decides these things?
Yeah, exactly. So it's there's a lot of stakeholders, and sometimes for the very large API changes, it can go all the way up to the executives. So yeah, there's a lot of different stakeholders involved when we assess the impact. Yeah.
Great. Another question I have that I'm just going to toss up here for you guys is, what are some of the limitations or challenges with the technologies that you use right now? I guess we can talk across the board. Everyone probably has some tools they want to complain about.
I can start. One of the limitations of the APIs to the data system that we ran into was that for a given data set in the data system, you can have multiple versions of a schema. So you can define what the data will look like, and then you can say add a field to the data. And when you use the API or the client libraries to access the API to get the data, you always get the latest version of the schema. And so if you are not equipped to, if your application is not equipped to handle that updated schema, you might run into some issues because compatibility issues. And so one way we try to get around that is that we have the schema on the application side so that we can verify that it matches what we expect. And if it doesn't, then we would just pretend that the data doesn't exist, and we'll log it. We'll log it, and then we'll look into it, because if you see a lot of these things show up, then we know that something went wrong, probably on the data side, like someone may have made a mistake, added a new field that wasn't expected, and so it just helps mitigate this kind of risk.
And I
Robert?
guess just
Sorry.
Sorry.
No, go ahead. Go ahead.
And just to add to that, again, the issue of latency, we couldn't pass back data in real time because of the tools that we used. And again, we wanted to ship this very quickly, so we decided to go with Google's BigTable for providing data to the front-end side. And that was something that maybe we want to improve on in the future.
Robert, challenges on your end? Limitations?
Not too many limitations or challenges necessarily. In terms of like the technologies, we are definitely limited to use Ruby because that's what we use internally for our app. But beyond that, no, nothing too crazy.
Any workarounds or anything like that that you're using that people could possibly use themselves if they're in the same situation?
We did find that for our API changes and API versions, I mentioned that they're defined in a YAML file. They are backed by this useful tool that we call frozen record, which allows us to like translate YAML files into objects we can use in our code. And we primarily chose YAML because it's a really static store. We didn't feel that we would be needing to like add versions all the time, so it didn't justify having a real database column in our production database. And similarly with API changes, the process of actually updating the YAML file as part of the PR process, pull request, so how someone adds code to our code base, was a very nice feature as well, because we were able to review every single API change and build bots around those new additions to that file. Whereas if we used a like database table, like people could arbitrarily add those through a SQL client or through other various different ways. So we really liked the YAML file format for storing this sort of information, and we do it throughout our code for many other things. So yeah, not really a challenge or a limitation, but more of a design choice that we came up with.
So one of the challenge and the limitation that UX run into is when we look into the data for across all apps, apparently there are high traffic apps and low traffic apps. So one thing we currently surface in the app index page is this status. So there's like red, yellow, or green. On the red and yellow status, by default we use 30 days. So if an app made any breaking call in the past 30 days, we'll surface that information. And the challenge is when an app is recently fixed, that status will still be up for 30 days until 30 days pass. It will like turn into an okay or good state. And I think that's basically one of the limitation we have, because if we want to shorten the time window to like 1 day or 7 days, there is like this risk that many app developers, their app isn't super high traffic, but maybe they can't see when they actually already made the API call, but we like in past 14 days, let's say, but we only surface 7 days data, then there is a risk for them to miss anything, the information we want to deliver to them. So there will be always like a trade-off between, do we choose to cover more like nuance of the developers we have on the platform, or we want to be accurate with the information. I think that is the area continually we'll also be looking into how we can improve on that.
Great. I have another question now. Is there more you'd like to do to help developers adopt breaking changes? And what features might you guys see in the future? Robert, let's start with you, since you dropped off and came back again.
In terms of like specific product roadmap, I don't have a clear idea of what that is.
We probably shouldn't be talking about that right now anyway, should we?
But is there more we'd like to do to help developers adopt breaking changes? Definitely. I think like part of the DNA of Shopify is to make these sort of difficult transitions as easy as possible, because we love it when developers build in our platform. And we're extremely grateful that we have such a great ecosystem that does build in our platform. So yeah, like I don't have a specific answer to that question, but definitely would love to help do as much as we can.
Anyone else want to add?
And also I think after the API House report was released, and after this first deprecation, we actively monitor all the feedbacks we hear from all the channels. And we definitely feel that those feedback will help us make the right decisions for the future. And we're still actively monitoring them. So like I think the feedback is super valuable to us, and definitely we'll look into those and take those as a source of truth for us help us make further decisions. So definitely it's not saying we think we're perfect right now, but I think on the contrary, we're just only at the start point to create a like this deprecation practice and help people to adopting future API, breaking API changes.
Great, that actually ties in well to our next question, which is, can you talk about the developer support channels that are that we use, help desk, developer forums, Slack instances? Who, we can't really talk about how many people monitor these channels, but who are the people that monitor these channels? Any of you guys want to start off? Any of you guys have like an idea?
I know that we have a lot of developer advocates that do a lot of work, whether that be on Twitter, but also on our forum, answering questions. And then obviously our support agents as well are a very valuable resource who can help you get directed to the right place.
Specifically talking about the API health report that just came out in the first deprecation, where are the best places for developers and partners to provide you guys with this feedback? Or is there like a dedicated place they can go to? Is this the forums, Twitter? Where can they get this information to you guys? Anyone?
I think the forum. Sorry, go ahead, Robert.
I was gonna say, yeah, I think the forum is probably the best place for that kind of like long form feedback. But yeah, like we're very active on Twitter, as you know, Anita. So we're always monitoring that. So if you have product kind of suggestions or feedback that are just short form and you want to let us know, we're always watching for that. And in fact, when we launched the API health report, there are some tweets that we received from some partners giving it praise, and our team absolutely loved that. So wherever is easiest for you, we just want to hear it.
Yeah, so at Shopify Partners and at Shopify Devs, I'd say at Shopify Eng, but I don't even know who I'd send those tweets to, so I would send it to those guys. But I know the forum is a big place for most of the feedback that I know the team looks at. So that really is the best place for most people, is to use the forums and put your feedback in there. It's actively monitored. So, okay, we got 8 minutes left, so please get your questions into the chat. We love to answer them for you. I
have something I can share that I think is pretty interesting about this project, if there's no questions.
Yeah, let's get some extra information here. And why wasn't it part of the presentation first off?
Well, like more specifically talking about the project as a whole, one of the best parts of working on this project is how multidisciplined it is. So like working with Shooting on the UX and Rishtia on the data side of things, that was awesome. And I think like one of the really cool parts about this is because we've constructed this infrastructure to create the data and have it in a very readable form. It has allowed us to create a bunch of other features and services around it, aside from just the API health report. An example of which is something I personally worked on was the breaking change emails. So the automated emails we send out on a, like, I forget the exact cadence, but like 5 weeks prior to a deprecation, we'll send you an email about which apps are affected, which breaking changes, and kind of link you to the API health report. I just wanted to call that out because I think it's really cool how we took what we built for the initial problem of building the API health report and used it to enable some of these other really cool automations. And so I think that ties back to that original question of like, what other features could we build? There's so many, because now that we've done the foundation, lots of really exciting, cool things that we could do, and that when given the time, we would love to do. But the email system is a really cool thing that I really like. So yeah, that's all I wanted to say.
So the emails didn't exist before. Basically, after the API health report came in, the email campaign basically started after that.
They did exist, but it was a manual process within our team. So we had a marketing automation team. They were working on that through their tools and stuff. But it was I know from just from their experience that it was a very manual process and not too enjoyable.
I do our newsletter, I know.
Yeah. So basically leveraging the data that Vrishti and the data team put into Panama, our data warehouse, was really beneficial to allow us to build an automated system where it took the workload off of the email marketing team. So just another win from this project.
Any other wins you guys want to share? That was kind of a lovely little story. And we could like to hear more if there's anything like that. Like, it's great that you know, we have a team here that's across Shopify, basically across R&D almost. So let's talk.
I can talk a little bit since we still have time. I want to echo what Robert mentioned about this cross-discipline collaboration. So I think because, as we can tell, this is a really technical term, team, and as a UX designer, I joined the team. Like, people like within this team, maybe like not everyone understand how to collaborate with UX really well. And like as a UX designer, I mostly work with the R&D side of a team. And I think this project enable like other disciplines how they see UX a bit differently. I think that's beneficial for the team in the long term because we can now see the result of how cross-discipline collaboration could work really well, deliver good results. And from a UX perspective, I can see not only the R&D side, but also the operational side and how to like make impact across the board. So we are this better unified team. And when we tackle any future project, we'll leverage those knowledge and experience to create this coherent experience for our developer communities.
Great. And Data, do you want to add to this too?
Actually, I want to circle back on the question about data freshness.
Oh, yeah.
One of the things that we did look at when we were trying to decide the frequency of like how what's the latency that we choose, we looked at how frequently the calls were being made. There are different types of apps on the system. There are some that make a call like every hour and some that make a call like 30 days. So we did some analytics behind that to also decide that, okay, an hour is probably good enough, at least for the apps that are making very frequent calls, to show and to capture the calls and the updates that happen within that period. So that was one of the other reasons why we chose to have an hour latency. And as for, sorry, I don't remember the question. But,
oh, it's okay. Don't worry. No, it's like coming back to the latency question. That was great, though. Actually, Andrew's shared some links in our chat for the support channels. If you guys want to check it out, there's a partner dashboard. You want to talk to Shopify devs on Twitter, and the APIs and technology community forum is also the best place. This stuff will also be in the wrap-up blog posts. They're in the chat right now if you guys want to check them out. And we're coming to the end, and I want to thank you guys all for being here. We will send everybody a copy of this this video after we get it cleaned up and published on YouTube. So you guys will all get that. Thank you for joining us, and thank you for asking your questions. Thank you, all of you guys, for being here and participating in this and being in the hot seat with me. I hope you have a great day, and I hope to see you next month. look out on Twitter for our next ShipIt event in September. Oh my God, it's September already. What is going on? Summer's over. See you guys.